Okay, this is the revision of electric current O level or Igcse level. Okay, now at first come to the topic, quantities involved with this electric current topic. At first, charge symbol we use for this is Q and unit is coulomb. Current I ampere. Voltage or PD, it is V, unit is also P, but it is a volt, right? Okay, EMF is also similar to PD. Its symbol is E and unit is V, volt also. Resistance R, unit is ohm, ohm. Then power. Okay, before that, work done or energy, work slash energy, E. It is also E. It is joule. Power, P. It is watt. So these are the main formulas which will be used, which are used generally in this topic. Now come to the formula. Formula. First one is I is equals to Q by T or Q is equals to IT. This is one formula, right? Another formula is Q equals to NE, where N is the number of electron. You know, electron movement most of the time create current. So, sorry, N is the number of electron. N is the number of electrons. E is the charge of one electron 1.6 times 10 to the power minus. So two formulas are Q equals to IT, memorize these two, and Q equals to N. Next one is V is equals to IR, clear? Or I is equals to V by R, or even you can memorize R equals to V by I. Now energy is equals to V into Q. Okay, V into Q, or it is VIT. Now come to the power. Power is what? Energy by time. So time cancel out. So power P is equals to VI. Power P is equals to VI. So these are the formula mainly. Now I have to learn different circuit symbol. These are some of them. Cell connecting leads is not proper notation. Proper notation is this is the battery. Many cells are added to make it. Switch open, switch close is this. Thermistor, LDR, lamp, resistor, variable resistor. Along with this other diode, and LED. Okay, these are circuit symbol. So we are revising electric current. Look, next part is, look, this is a cell. The voltage that is written in a cell is the EMF of it. If it is 6 volt, this is source potential, right? It is the maker of potential. It provides voltage or PD to the potential, to the devices. Clear? If you connect single device, all this voltage will be given to that single device, 6 volt, right? It is the supplier and it is the user. The amount that will be supplied, totally it will be used by it. Okay, now every device has some resistance, whatever it is, lamp, resistor, TV, fridge, any electrical appliance introduces resistance, right? And separately resistors also introduce resistance. So if a resistor and a lamp are connected in this way, still if it is 6 volt, then this time voltage will be divided into two parts, and it will be divided according to the ratio of resistance. As for example, if this lamp has a resistance 30 ohm and it has resistance of 15 ohm, what is the ratio of resistance now? 15 into 30. What is the resistance? 30 by 15, it is 2. So 1 is to 2. That means if it is x volt, it will be twice x volt. And again, plus x must be 6. So it will be, x will be what? 2 volt. Clear? Okay. Or you can solve it in this way. What? If it is 1 volt, it will be 2 volt because resistance ratio is 1 is to 2. But the problem is 2 plus 1 is 3, not 6. Okay, so try with the second one, next value. If it is 2 volt, it will be 4 volt. So 4 plus 2 is 6. This is the way. Look, if it is 10, if this resistance becomes 10, then 1 is to 3. So how can you solve this? Okay, common ratio, if it is x, then 3x plus x, 1 is to 3, right, is equals to 6. So 4x equals to 6, x equals to what? 1.5. That means it will be 1.5 volt, it will be what? 4.5 volt, right? 4.5 volt. This is called potential divider rule. Right, in series connection, if two resistor or two devices are connected, this is series connection, when you connect them one after another, then whole voltage will be divided, okay, according to the ratio of the resistance. Look, this is a battery of 12 volt. This is called output. Okay, if these two wires are connected in this way, these two A and B are called output terminal. Why? Because if you connect any device across it, you can give some voltage to that, right? Main voltage will be what? Divided into two, and one fraction will be divided to the output. Clear? Okay, this is called V out or output voltage. Okay, it is also divided according to the ratio of resistance. As for example, look, if it is 40 ohm, if this resistance is 40 and you want 6 volt right now here, Then choose the resistance for this resistor 40. So 1 is to 1 ratio. So what will be the output voltage? 6 volt, right? So voltage between these 2 points A and B will be 6 volts. So if you connect a lamp, right, between terminal A and B, then it may get a voltage 6 volt, right? Okay. Now, if you want to change the ratio, as for example, you want 9 volt now. So what will be the choice? You have to change the resistance values, right? You can do two things. What? You can change this one by 20. It will be 1 is to 2. Oh, you want 9 volt, right? Oh, it is what? 1 is to 3, right? 3 volt will be here. So the resistance ratio will be 1 is to 3. So change the resistance values so that the ratio becomes 1 is to 2. So you can make in this way, it is 20, it is 60. Resistance ratio is 1 is to 2. Voltage ratio will be 1 is to 2, right? So if you connect the device to the output terminal AB, it will get 9 volt. This is called potential divider. This is called potential divider, right? Okay. Now, look, it's a regular ratio, but if it is irregular ratio, then what to do? Don't worry. If the question is not regular ratio, 9 volt as a V out, I want 5.5 volt output voltage here, right? This ratio is given, sorry, this resistance, only one resistance value is given here, 100 ohm. What resistance, okay, do you expect here? Very simple. If you subtract 5.5 from 9, it will be what? 3.5 volt, right? So voltage is there, I am not using it, but this resistor, right, it voltage is there, still voltage is there to this resistance resistor, right? R1, R2. Now what to do? You know the formula. What? Voltage is divided according to the ratio of resistance. That means V1 by V2 is equals to what? R1 by R2. V1 by V2 is equals to R1 by R2. Okay. If you consider V1 is V out, then V out by other voltage, okay, V2 will be, okay, R1, look, corresponding voltage V out, so corresponding resistance, sorry, resistance, so it will be 100 divided by unknown resistance R2, clear? Or 5.5 by 3.5 will be 100 by R2. So easily you can solve it. So this is the way, okay, to solve potential divider problems. Okay. Another device is potentiometer. Look, in this way you can provide, right now voltage 5.5. Now if you need 7.2, now you have to again change the resistor. You will look for new resistance pair, right? Resistor pair of desirable resistance. In that case, if you can use a coil type resistor or a long wire as a potential divider, then you can provide any fraction of input voltage to the output. As for example, this is 12 volt, right? You want any voltage. You want to, this is a wire which can be, okay, moved up and down. You can slide it. This is the output voltage V out. It's a voltmeter, you can assume it. This is an emitter. This is the lamp. Look, you want to know the IV characteristics of the lamp. That means for different voltage how this lamp behave. Okay, what is the current of it? If you want to determine it, you have to use the potential divider. Look, if you right now this sliding contact, if you keep it exactly at the middle, so logically this bigger resistor, it has been divided equally. So what will be the output voltage? You expect it 6 volt now, and for that 6 volt there will be a current. Clear? If you move the sliding contact down, then what will be? Then if you move the sliding contact in this way, then what will be? Resistance of the lower part, resistance R1 has been decreased, R2 has been increased. So what will be? More fraction of input voltage, sorry, less fraction of input voltage will be provided to the output. So lamp will get low voltage. And even if you, okay, push it to the lowermost point, as for example at A bottommost point, then what will be? The voltage will be 0 to the output. If you move it gradually upward, the voltage will increase from 0 to 1, 1.5, 2, 2.5, right? 3, 4, 5, 6, 7. Then finally, if you move this to the topmost point, that is to point B, all the 12 volt will be provided to the output, right? So you can make a table with column heading V of the lamp and I of the lamp, right? And you can collect data for 1 volt. 0 volt definitely current will be 0. For 1 volt there will be a current, say 0.1. For 2 volt, okay, there will be a current, okay, it could be 0.2 or 0.19, whatever. So you can collect data, okay, of V and I for different voltage, and then you may plot the graph, IV graph, to check that it has desirable shape, okay, curve like this, right? You know, if a body, okay, obey Ohm's law, if a conductor or any device, as for example this resistor, rectangular resistors that obey Ohm's law and lines are straight exactly, resistance value is constant for ohmic conductor, right? But for filament lamp, this is the graph for filament, it does not obey Ohm's law. Its resistance increases when voltage is increased and the curve bend towards the voltage axis. Another device is thermistor. When you increase the temperature of the thermistor, its resistance decreases. Okay, this is thermistor. Resistance of the thermistor decreases due to temperature rise. Clear? And for thermistor, IV graph will be like this. It will bend towards the current axis. Got it? Okay. Another device is diode. Diode allows electric current in one direction only. As for example, look, this diode will conduct electric current and this lamp will glow because this is called forward bias. Look, current direction and this diode Okay, pointing current, right, is in the same direction. So in this is called forward bias. Forward bias. Lamp will glow. Clear? Now if you reverse any one, either diode or cell, lamp will not glow, current everywhere will be stopped. For example, if you reverse the cell, it is negative voltage now, right? Then current will be blocked totally. Lamp will not glow at all. Actually, this diode disconnected the circuit. There is a gap. Assume that, right? It introduces infinite resistance. This is called reversed bias. Lamp does not glow and resistance of the diode is infinity. That's why it does not introduce current. In forward bias, resistance is not infinity but very small. Sometimes we consider it zero. Resistance is not zero, but it has a very small value, right? Most of the time we consider it zero. Now, what will be the IV graph? Look, if you use a potentiometer to provide different voltage across a diode, if you start increasing voltage, if you slide it, okay, from A to B slowly, very slowly, then this is called forward bias for the diode. Why? Because look, current will start from this. At this point, current has two pathways. One will be through the diode and the one directly. Current will split. Then will join again. Now, if you increase this voltage starting from 0.1 volt, 0.2 volt, how can you increase that? Using this sliding contact. If you move it up starting from A, it will increase gradually. Clear? 0.3 volt. Look, this is called positive voltage. You are applying 0.1, 0.2, 0.3, 0.4, 0.6, right? Like this. 0.1, 0.2. In this way, when if it is a silicon diode, when voltage is about zero point 0.7 volt, then look, previously the graph was almost zero or little current, right? Then it almost becomes vertical like this. This is actually positive voltage. Current is also positive, but the graph is like this. Clear? But if you reverse the diode connection or reverse the battery connection, anyone, okay, if you reverse the battery connection, look, the positive side is now going to the negative side. So it's a negative voltage, minus 1.5. Okay, look, plus minus has been reversed. Previously, this side was positive, but the same side is now negative, right? This side is positive. So if previously it was 1.5 volt, now it is 1.5 volt but negative. If you again move the sliding contact, okay, A to B, voltage will be increased, but negative value will be increased, minus 0.1, minus 0.2, right? Minus 0.1 volt, minus 0.2 volt, minus 0.3 volt. So for that, okay, there will be no current. So to the left side, it will overlap the time axis. So this is the graph for diode. LED is another device called a light emitting diode. What I said, light emitting diode. Look, in that case, diode, whether it is conducting or not, you can confirm it looking at the lamp or connecting ammeter to the circuit, right? But LED glows itself when there is a current. Okay, this is a forward bias. Look, normally we don't connect a single LED to the battery because LED cannot take bigger voltage, it burn out. So this is a safety resistor. So if you connect it in this way, look, LED glows, it may not glow, okay, if it is reverse bias it will not glow, but the symbol, this arrow will be there to show that this is a LED. Clear? This time this LED glows. Why? Because it will allow current through it, it will glow. But if you reverse this battery connection, this time current tends to grow up in this way, right? Current tends to grow up in this way. But this diode LED, right? First of all, it is a diode, then light emitting. So it will block the current and it does not glow. It does not glow. So a LED, it has all property like a diode. An additional property is when it conducts current, it glows itself. Look, this is LED. Look like. Oh, these are lamps. These are LEDs, glowing LEDs. Okay. So when they conduct current, they glow itself. Last one is LDR. This is light dependent resistor. Graph is like this. This is the brightness of light. This is the resistance. When brightness increases, resistance value decreases in this way. That's it. Nothing else. Right? What could be the question? This is a LED. This is an emitter. Okay. This is a lamp. Now, if the question is if the distance is decreased, then what will be the current rating? Very simple. When you bring this lamp nearer to the LDR, if you move it down, then brighter light fall on the LDR. So what will be its resistance will be decreased. Voltage is, look, every battery is a constant voltage device. Every battery is a device of constant voltage. So when resistance of the LDR is decreased, circuit current will be increased. That's it. Voltage will be same, but the circuit current will be increased. Okay. Now come to the series parallel. Look, this resistor and lamp. Okay, I'm connecting two resistors. These two resistors are connected in series, and these two resistors are connected in parallel. Assume that this cell is of 2 volt, it is also of 2 volt. It is R1, it is R2. R1, R2. R1 is of 4 ohm, it is of 2 ohm. 4 ohm, no. 6 ohm, 3 ohm. 6 ohm, 3 ohm. Look, this is first one is a series circuit. Memorize, in series circuit current same everywhere. But in parallel connection, voltage remains same. Total voltage and individual voltage will be same for parallel. That means if you connect a voltmeter in this way, the overall voltage will be 12 volt, right? But if you connect two other voltmeter individually across these two resistors, that voltage will be 12 also. That is the fact of parallel connection. Overall voltage and single voltages are same, right? Current will be different. Okay, not 3 ohm, it is 6 volt, right? 12 volt. Again, the total voltage supplied is 12. Individually, voltage across every resistor is 12 also. So what current will be there through R1? That current will be 2 ampere. What current will be there through R2? R2 is what it was 3 ohm, right? So what current will be there in the lower pathway? 4. Note one thing, resistance in parallel connection, smaller the resistance, higher is the current, right? R2 is 3 ohm, so current is 4. So here main current is 6 ampere, it has been splitted, right? But with opposite ratio, bigger the resistance, smaller the current. So with opposite ratio. Okay. In parallel connection, advantages is you can connect switch individually. If you connect two switches in this pathway, right? When you turn on of them, you can individually give current to R1 and R2. Even look, the current is now 6 ampere, right? In the main supply. So what do you think if this one is removed? Then what will be? Will this current be 6 or still will be 2? It will be still 2 ampere. Now if you may ask a question where the other 4 ampere is. Actually, I told you for a battery or cell, current is not a constant factor, right? Depending on the demand of the circuit, it can increase or decrease the current, but the voltage is same. Previously, the lower resistor was demanding current of 4 ampere and upper one is also demanding 2. It made 6 ampere current. Now the lower one is not demanding, so it will not make it. Current immediately it will be dropped to 2 ampere. Will drop to 2 ampere. Okay. Main current from the battery is shared, right? If one goes off, then what will be? That current will not be made by the battery. That's it. In this case, already you know the main voltage will be divided, ratio is 1:2. So this will be what? 4 volt, this will be 8 volt. Very simple. And a single current will be there, right? And that current will be what? 12 by 9. That current will be 12 by 9. That's it. Okay, this is series and parallel connection. Note one thing, if you want to measure that current, connect an emitter here. Emitter is connected in series, right? And resistance of emitter is supposed to be 0. and voltmeter resistance is supposed to be infinity so that it does not receive any current of the main supply. That's why theoretically it is infinity, but practically it is very big in comparing to compared to the circuit resistance. Clear? Okay. Now color code of resistor. Look, if you look at the resistor, look at this. Values are not marked, right? Values are not marked. Actually, okay, values are written by color, right? As for example, look, you know, number are 1 to 9. So here number are 1 to 9, okay, but it is written by color. Okay, look at this. First color is value. When we write 0, okay, instead of 0 we shall write, okay, we shall give a black mark here, right? If we want to write 1, we shall give a brown mark like sign language, right? When you want to write 2, just give a red ring around the resistor. It's a ring actually around the resistor, right? If you want to write 4, give a orange ring. Okay, but look, we express values in terms of 3, okay, with the help of 3 rings only. Last one is tolerance. It will be either golden or silver. If it is golden, that means there would be 5% mistake. The value, okay, noted here by the color ring color, okay, color rings. Actual value could be 5% more, less, or within this. Clear? If it is silver, that means 10% mistake could be there to the number marked there. Clear? This is the table. This table will be given there. You don't need to memorize. B, there is a rhyme. Okay, you don't need it. B, Roy, good boy, very good worker. We used to memorize it. Okay, in our student life, because they in that time, I think still now in national curriculum they don't provide this table, but in your case table, okay, will be there. Now look, if you want to know the resistance of this one, this one, then look, this is the first ring, it is red. Go to the table, red is 2. Okay, so for this one, first color is 2, so red, so it is 2. Second one is violet. Go to the table, violet, where is it? Violet for, okay, 7 for violet, so 7. Then this is green, right? Okay, for green it is what? 5. Now what do you think? It will be 5? No, it is actually multiplier. That means it will be 10 to the power 5, or another way is 2750. This is good. 2 1, okay, 5 zeros. It's a very big resistance, right? Okay, so in that way you can find out the resistance of other resistors also. What will be? Guess. First one is blue, right? What is the value for the blue? Blue. This is blue. What is that? 6. Look, first one is 6. Look at this, 6 written here. Second one is red. Red is 2, right? Okay, so it is 262. Next one is black. Black means no zero, or 10 to the power 0. 10 to the power 0 means 1, right? If this black is replaced by brown color, then it will be 620. Note one thing, if this black is replaced by brown color, look, for brown it is 1. So if it is replaced, black is replaced by brown color, then the value would be 62, 6210. Right, brown is 1, that means 10, or 10 to the power 1, multiply it by 10 to the power 1. So it would be 620 ohm. It is gold, 5% plus minus. That's it. Now come to the next one, resistance of a conductor. Look, if it is a conductor, normally we use resistance wire to introduce resistance. Okay. If it is a resistance wire, normally we use tungsten or nickel wire. Look, resistance actually depends on this area of cross section, pi r square. It may have rectangular cross section also, and the length. There is a directly proportional relation. That means longer the length, higher the resistance, thinner the wire, higher the resistance. Or most of the time you need this ratio, memorize it, very important ratio. 1 by area 2. Why? Look at this. 2 1 2 1. Y R and L are directly proportional. Directly proportional means what? They are alike, they are friend, right? If one increase, another one will increase. But with area, it has an inverse relation. That means if one increases, another one will decrease. If area becomes more, resistance will be less. That means if you use a wire of what? Bigger diameter, same length, but diameter is bigger, then its resistance will be less, right? So it has an inverse relation, 2 1 2 1, 1 2 for area, right? Okay, so you may use this to determine the unknown resistance. Okay, it's a very important ratio. That's it. Last one is use of fuse. Fuse is used actually to protect an electrical appliance. As for example, look, our supply voltage is 220 volt. You have a TV. You connect it to the supply. TV has resistance 100 ohm. Now the TV is operated by the current I equals to V by R, right? V by R. So 220 by 100, it will be what? 2.2 volt. Clear? Okay. So TV is operated by 2.2 ampere. This is called operating current. That means this TV will work properly. Its internal circuit will work safely. TV will be functioning if you provide 2.2 ampere current. But for unexpected reasons, for example, during thunder or bad regulation, okay, uh, in power station, if this voltage becomes high, main supply voltage for unknown reason becomes high, as for example, it became, okay, say it became 1,000 volt for any unexpected reason, then this current tends to be 10 ampere. Look, the internal circuit of the TV has been made to work for 2.2 ampere. If you suddenly give 10 ampere there, it will be heated up highly. So its internal circuit will burn. Clear? So if you want to save it, connect a fuse here of 3 ampere, okay, to the circuit. Rating of fuse will be a bit higher. It must be in whole number. It is 2.2, you cannot give it 2.3, right? Nearest whole number. This is the symbol of fuse. Don't think it a resistor. It is fuse. So this time it will use a 3 ampere fuse. Don't think that fuse can reduce the current from 10 ampere to 3 ampere. No, it can burn itself. It sacrifices its life to save the TV, right? So normally when the voltage is 220, when the voltage is 220 volt, look at this. The current is 2.2 ampere now, right? This is the main current in the supply, in the circuit. 2.2 is the circuit current. 2.2 is the circuit current. So fuse will look for the current, look at the current. It will see that current is 2.2. Okay, my leveling is 3 ampere. I cannot block that. Go, go, go. Right? It will be allowed to go through the TV. TV will be functioning. No problem. But for that unnecessary, unexpected reason, if the voltage turns to 1,000 volt, when current goes to 10 ampere suddenly, instead of 2.2, current became 10 ampere. Look, before the TV, damaging of a TV, fuse will be burnt. Okay? Within a moment, this fuse will burn. So TV is safe, right? And it will disconnect the circuit. So this is the function of fuse. So hope you understood. Okay. Now, formula for power and energy. Look, energy is voltage into charge, or VIT. Most of the time we use VIT. That means how long the device get the current is very important here, right? And for power, Power means VIT divided by T. So power is Vi. Vi in Bengali we call it Vi. Vi means power. If you have Vi, big brother, Vi means big brother. If you will have power, right? So P means Vi, Vi. Okay, you can change this formula to v is equals to ir. If you mix it with it, it would be I square r or v square by r, but most of the time we use vi. It is your choice, depends on the data given there. Now assume that this is a 220-volt supply and you are connecting that same TV to the circuit. It is of 100 ohm. So what will be the current now? 2.2 ampere. So what is the power consumption of power consumption? That means it is consuming power from the supply. Supplier supplies the power, supplies the energy. So what will be the power consumed by the TV? It will be 220 into 2.2, right? 220 into 2.2. 484 watt. Clear? Now if the question is how much energy, when the term is energy, time must be there. So what energy, electrical energy is consumed by it over a time of 10 hour, then the answer will be VIT. Product Vi is the power, answer is already known to you. So 484 into time 10 hour, 10 into 60 into 60. Okay, energy has a unit joule, so if you want the answer in joule, you have to convert the time into second. So the answer is 1742000 joule. Value is too weak, right? Now if the electric bill is taken with the joule unit, right? Look at the number, it is too big to handle, right? So better we reduce this value changing the unit, and that smart unit that we use to pay our electric bill is what? Kilowatt hour. This is the unit of electrical energy. Instead of joule, right, we use it to collect bill. Government use it to collect electric bill from us, right? This is unit of energy consumed. So in terms of kilowatt hour, what would be the value? Look, energy, you know, energy is equals to power into time. So when energy is energy unit is joule, that means it is watt into second. So joule is also a product of power and time with unit watt and second. But what if you express the power in kilowatt and time in hour? This is more realistic because normally we operate devices for a few hours, right? So kilowatt into hour, it is also product of power in time and time, right? So it must be energy. Unit will not be joule, but it is energy. So it is kWh, kilowatt hour. Got it, everybody? kilowatt hour. So in that case, what will be the electrical energy consumption of this TV by 2 hours? Look, power into time. It was 484 watt, but I need this value in kilowatt. So divided by 1000 into time. Time is 10. So what will be? It will be 0.484 into 10, that is only 4.84 kWh, kilowatt hour. Got it? Now, if 1 kilowatt hour energy cost 5 cent, then what is the total cost? Total cost is 4.84 into 5 cent. 4.84 into 5 cent. So it will be 20.42 cent. Right? Okay. So today up to this, we covered 80% of syllabus of O level except SC and TC. Thank you. Bye bye everybody.